with these next ones, again, we're going to be identifying based on the equation. It might help to look at a graph of some of these before deciding which one it is. So maybe go to y equals and type this in as x parentheses 2x plus 3. And then let's press zoom 6. And you can see it looks like a quadratic, and it bottoms out, so it has a min. So I'm going to try to put these functions over here, maybe just big enough so that you can see them still, but you can clearly see that's a quadratic that bottoms out. And so our choices are linear growth, quadratic local max. This is a quadratic local min, so we need to circle the local min right there. All right, let's try the next one. Go to y equals and hit clear. And type 3 parentheses 1 minus 2x, close parentheses minus 4. And if you clean that up, you should see we got a line here. But it's a line that moves downward. From left to right, that line moves down. So you always start at the left and move towards the right. So that's linear decay. All right, the next one, let's type it in. If we go to y equals and clear that out, we can type in 2 plus parentheses 1 divided by 2, close parentheses, caret x, and then graph that one. So that's an exponential that's getting smaller and smaller and smaller, so that's exponential decay. So exponential decay because it's going down forever. All right, try y equals again and clear this off. So next one's going to be 3 times parentheses 2, close parentheses, caret x plus 1. So you just type it in like that. Let's graph that one. So this is exponential growth because from left to right it goes uphill. Alright, the next one. So y equals, and just type in 2 minus 3x squared plus x. So it's a quadratic again, it's making that U shape, which is called a parabola, and this one has a maximum because it's at the top, so it's quadratic with a local max. And then the last one, I would probably type in parentheses 1/2, close parentheses, so I could type the 1/2 then x minus 1. And that looks like it's a line that's always going uphill, it's always growing. So that would be linear growth. They also give us some tables to look at, and in this case right here, we can first start by looking at how the x changes. So the x goes up by 1, it goes up by 1 again, goes up by 1 again, so it looks like it just keeps going up by 1. And the y, or the a of x in this case, is going up. 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 13, 9 plus 4 is 13, and 13 plus 4 is 17. So when you have a consistent first difference ratio and it's going uphill, it's going from 1 to 17, that would be linear growth. It's linear because the first difference is the same and it's going uphill. All right, let's continue looking at the rest of these now. Let's try the next one, and this one's going, again, it looks like all the x's are jumping by 1. So we have a consistent change for the x that should help us decide what the bottom one is. All right, so from 1 to 2 is up by 1. From 2 to 1 is down by 1. From 1 to negative 2 is down by 3. And from negative 2 to negative 7 is down by 5. So again, if you're not sure how to get these differences, you just subtract the second minus this. So 2 minus 1 is 1. 1 minus 2 is negative 1. Negative 2 minus 1 is negative 3. And the last one, you can see I just simply did negative 7 minus negative 2. That's how I got the negative 5 right there. All right, so the first difference is definitely not the same, so it's not linear. Let's look at the second difference. All right, so the second difference would be from 1 down to negative 1 would be down by 2. Again, you could subtract these two if you wanted to. And from negative 1 to negative 3 is down by 2 again. And from negative 3 to negative 5 is down by 2. The second difference is the same, so that's a quadratic. And in this example right here, we need to kind of see if it's like how it changes. So if I plot these points, let's kind of look at a quick rough sketch of what we think these points would look like if we plotted them. So if I plotted the point 1, 1, that would be over 1, up 1. If I plotted the point 2, 2, that would be over 2, up 2. If I plotted the next point 3, 1, that would be over 3, up 1. If I plotted the next point, it would be over 4, down 2. So you can hopefully see just by plotting a couple of those points, you're going to have a parabola that looks like this. So we know it's a parabola or a quadratic, and it looks like because after we plotted the points, that right there is going to be a maximum. So this will be a quadratic with a local max. So it's a global max too. Okay, let's try the next one. So again, it looks like the x's are being nice and uniform and changing at the same rate. And from 0 to 2 is up by 2. From 2 to 6 is up by 4. From 6 to 14 is up by 8. And from 14 to 30 is up by 16. Alright, so since these are multiples of each other, this looks like it's going to be exponential. As a matter of fact, you can see that if you do a second difference, you'll still get the same multiple. From 2 to 4 is 2, from 4 to 8 is 4, from 8 to 16 is 8. So no matter how many differences you go, it's always a doubling effect, and so therefore this one must be exponential. And since it's going from 0, 2, 6, 14, 30, it's growing as it moves to the right. So this is going to be exponential growth. Oops, sorry, just moved a little bit. I just want to write down why those were each the type of functions we thought they were. Alright, let's look at these last set here. Start back at the first one. Alright, again it looks like they're nice and the x's are jumping at a consistent rate of 1. Alright, and then from 3 to 0, that's down by 3. And again, you can just, 0 minus 3 is negative 3. And the next one from 0 to negative 1, that's going down by 1. From negative 1 to 0, that's up by 1. Again, if you did 0 minus negative 1, that would be positive 1. And then from 0 to 3, that's going up by 3. So it looks like it's definitely not linear because the first difference is not consistent. Let's go from negative 3 to negative 1. That's, again, if you subtract these two, you'd find that from negative 3 to negative 1 is up by 2. From negative 1 to positive 1 is up by 2. And from 1 to 3, you had to add 2, so that's up by 2. So the second difference is the same, so this must be a quadratic. So again, if I kind of plot some points here, it might help us to kind of estimate what this is. Alright, so if I plot the first point, 0, 3, that would be left, right, 0, and be up 3. Next one is 1, 0, so that would be right there, 1, 0. The next one is 2, negative 1, that would be 2 and down 1. Next one is 3, 0, so that would be right there. And then the last one is 5, 3, so that would be over 1, 2, 3, 4, 5, and up 3. I just realized that should be a 4. That's a typo. So let's fix that really quick. I just realized that should have been a 4. Alright, so this is a parabola or a quadratic with a min, because it bottoms out, so it's a local min would be right, or a global min in this case too. Alright, let's look at the next one. Alright, so they're being nice here. It's jumping up by 1, jumping up by 1, jumping up by 1, and this one is going down by a lot, so if I'm not sure I can subtract them, but it looks like 32. But anytime you're not sure about the difference, just subtract it. So in this case, 33 minus 65, you can see is down by 32. And then from 33 to 17, looks like it's down 16, but again we can do 17 minus 33 to get negative 16. And from 17 to 9, that looks like it's down by 8. Again, you could use a calculator if you wanted to. And from 9 to 5, that's down by 4. I'm hoping you're seeing, again, that this is a multiple. It's going down, it's multiplying by half each time for the differences. So since it's multiplying by a half each time, that's exponential. It's multiple, the differences are multiples of one another. So that one's going to be exponential, and since it's going down, it's exponential decay. Alright, the last one, again, it looks like they're nice to us and the x's all jump by 1. And from 9 to 7, that's down by 2. From 7 to 5, that's down by 2. 5 to 3, that's down by 2. Again, anytime you want to, you can subtract these with a calculator. 1 minus 3 for the last one, you can see is negative 2. So it's the first difference is constant, and it has a constant rate, so that's linear. And it's going downhill because it goes 9, 7, 5, 3, 1. So since it's going down, it's linear decay. Alright, I'm going to post some of these other reasons down here, and I'll stop, and good luck on your quiz, and please don't hesitate to ask your teacher if you have questions.